Welcome back, everyone. This is Emmy. In today's session, we'll be diving into the UML diagram for our project. Here, you can see our previous UML diagram, which had some structural issues and didn't fully capture the system's design. It lacked clarity in relationships, organization, and the proper use of object-oriented principles, which we've now addressed in our updated version. Let's go over the new UML diagram. I'll walk you through each class, its variables and methods to give you a clear understanding of how they contribute to the banking system. Afterward, we'll discuss the relationships between these classes, covering aspects like aggregation, composite aggregation, inheritance, and dependencies. The bank class is the central hub of our banking system. It holds key information such as the bank's name, branch code, address, and lists of staff, users, and accounts. Key functions include staff management, adding or removing staff; user management, adding or removing customers; account operations, creating and closing bank accounts; data retrieval, fetching specific user and account details, as well as listing all users and accounts; loan search, finding loans based on user information. This class provides the foundation for managing all essential banking operations. The user class holds personal details for each bank user, such as user ID, name, gender, DOB, phone number, email, address, nationality, PAN card, Aadhaar number, balance, and loan details. Key methods include getters like getUserID, getName, getEmail, getBalance, and getLoanDetails to retrieve user information and account details; setters like setName, setGender, setPhoneNumber, setEmail, and setNationality to update user data; financial operations, deposit and withdraw to manage account balance. This class is essential for maintaining user information and handling basic account operations. The bank staff class represents employees of the bank, capturing essential staff information such as staff ID, name, gender, DOB, phone number, email, position, salary, and branch code. Key methods include getters like getStaffID, getName, getGender, getDOB, getPhoneNumber, getEmail, getPosition, getSalary, and getBranch code to retrieve staff details; setters like setName, setGender, setDOB, setPhoneNumber, setEmail, setPosition, setSalary, and setBranch code to update staff information. This class plays a vital role in managing and updating the bank staff details within the system. The bank account class represents individual bank accounts containing key attributes such as account ID, account holder, a reference to the user who owns the account, balance, and transaction history, which is a list of transactions associated with the account. Key methods include getters, getAccountID, getAccountHolder, getBalance, and getTransactionHistory to retrieve account details and transaction history; financial operations, deposit and withdraw to adjust the account balance; transaction management, add transaction to record a new transaction in the history. This class is essential for managing each account's balance and transaction history in the banking system. The customer class represents a bank customer, with attributes including customer ID, a reference to the user object, account list, a list of the customer's bank accounts, loan details, a list of loans associated with the customer, and registration date. Key methods include getters, getCustomerID, getUser, getAccountList, getLoanDetails, and getRegistrationDate to retrieve customer and account information; account management, add account and remove account to add or remove bank accounts; loan management, add loan and remove loan to manage loans linked to the customer. This class enables the management of customer-specific details, including accounts and loans. The loan class manages loan details for a customer, with key attributes like loan ID, customer ID, loan amount, interest rate, loan term in months, monthly payment, status, disbursement date, and payment history, a list of payments associated with the loan. Key methods include getters, getLoanID, getCustomerID, getLoan amount, getinterest rate, getLoan term, get monthly payment, get status, get disbursement date, and get payment history to access loan information. Setters, set loan amount, set interest rate, and set loan term to update loan details. Status and payment management, update status to modify the loan status, and add payment to record a payment in the history. This class is essential for handling loan-specific information and tracking payments for each loan. The transaction class represents individual bank transactions, with key attributes such as transaction ID, account ID, transaction type, e.g. deposit, withdrawal, amount, transaction date, and description. Key methods include getters, get transaction ID, get account ID, get transaction type, get amount, get transaction date, and get description to retrieve detailed information about each transaction. This class is crucial for recording and retrieving transaction details associated with specific accounts. The manager class represents a manager in the banking system, with attributes such as manager ID, name, department, contact info, and team members. A list of bank staff members supervised by the manager. Key methods include getters and setters, get manager ID, get name, get department, get contact info, and set contact info to manage manager details. Team management, get team members to retrieve the list of team members, add team member to add a staff member, and remove team member to remove a staff member by their ID. This class allows efficient management of team members within a specific department. The cashier class represents a cashier in the banking system, with attributes including cashier ID, name, contact info, assigned branch, and transaction history, which stores a list of processed transaction records. Key methods include getters and setters, get cashier ID, get name, get contact info, set contact info, get assigned branch, and set assigned branch to manage cashier details. Transaction management, get transaction history to retrieve all transactions handled by the cashier, and add transaction to add a new transaction to the history. This class allows for tracking the cashier's transactions and maintaining their assigned branch information. The saving account class models a savings account within the banking system, with attributes like account ID, account holder, balance, interest rate, minimum balance, and transaction history, which logs the list of transaction entries associated with the account. Key methods include account management, get account ID, get account holder, get balance, deposit, and withdraw for handling basic account operations. Interest and balance requirements. Calculate interest to compute interest based on the balance, and get interest rate and get minimum balance to retrieve account-specific requirements. Transaction handling. Get transaction history to fetch all transactions for the account, and add transaction to log a new transaction. This class allows for easy management of savings account-specific attributes, including interest and minimum balance enforcement. The current account class models a current account within the banking system, with key attributes such as account ID, account holder, balance, overdraft limit, and transaction history, which stores a list of transaction records. Key methods include account management, get account ID, get account holder, get balance, deposit, and withdraw for basic account operations. Overdraft management, set overdraft limit to define the overdraft limit, and get overdraft limit to retrieve it. Transaction handling, get transaction history to view all account transactions and add transaction to record a new transaction. This class is essential for handling current account-specific features, including overdraft management. The fixed deposit account class represents a fixed deposit account in the banking system, with attributes such as account ID, account holder, deposit amount, interest rate, tenure, duration in months or years, maturity date, is matured, indicating if the account has reached maturity, and transaction history to log related transactions. Key methods include account details, get account ID, get account holder, get deposit amount, get interest rate, get tenure, get maturity date, and is matured to access core account information. Maturity calculation, calculate maturity amount to determine the amount available upon maturity based on deposit and interest. Transaction handling, get transaction history to view transaction history and add transaction to record a transaction. This class is designed for managing fixed deposit accounts, including tenure-based maturity calculations. First, we will look into inheritance relationships. User, customer. The customer class inherits from user, as a customer is a type of user within the system. Bank account, saving account, current account, fixed deposit account. Saving account, current account, and fixed deposit account are specialized types of bank account, each with unique attributes and methods relevant to their specific account types. Bank staff, manager, cashier. Both manager and cashier inherit from bank staff, representing different roles under the staff category. Next comes aggregation relationships. Bank-to-bank staff. A bank can employ multiple bank staff, forming an aggregation relationship where staff members are associated with the bank but exist independently. Bank-to-user. The bank manages multiple user instances, with users existing independently outside of the bank's ownership. Bank-to-bank account, composite aggregation. Each bank account is integral to a bank and cannot exist independently of the bank, forming a composite aggregation. User-to-bank account. Each user may own multiple bank account instances, representing a user account relationship. Bank account to transaction. A bank account maintains a list of transaction entries, with each transaction linked to an account but also able to exist independently. Loan to user. A loan is associated with a user, as a user may take out a loan that exists in association with them. Bank staff to loan. Bank staff can be associated with multiple loans, indicating an aggregation where staff members are responsible for overseeing loans. At last, dependency relationships. User to loan applies for. A user can apply for a loan, establishing a dependency as the loan is created in response to the user's action. User to transaction initiates. A user initiates transactions on their account, creating a dependency where the transaction depends on user interaction. Bank staff to transaction verifies. Bank staff members may verify transactions, indicating a dependency where transaction validation requires staff involvement. Bank staff to loan processes. Staff members process loan applications, creating a dependency on staff processing for loans to be approved. Transaction to bank account records in. Each transaction is recorded within a bank account, indicating a dependency as transactions are specific to account activity. Transaction to user linked to user. Transactions are linked to a user, indicating that transaction records are user-specific. Loan to bank account collateral. A loan may use a bank account as collateral, establishing a dependency between the loan and account in specific loan cases. Thank you for watching, guys. See you guys in the next video.